Hello guys, my name is Shreyas. I'm an educator at Unacademy. You can follow me on the Learning app as well. You can see my set of courses on the Learning app as well. This is a lesson about the nuclear power or the nuclear energy. Please do rate this lesson, review this lesson and share this lesson. And please do follow us on our YouTube channel, that is the Unacademy Engineering Curriculum Group channel. Thank you. So guys, let's start with our course Elements of Mechanical Engineering. So my introduction already given. I'm a BE Mechanical Engineering student. You can follow me at the Unacademy user platform mentioned over here. And nuclear power is the course we'll be dealing with, and the lessons pertaining to this topic will be discussed by me. So the target audience for this slide will be engineering students, general audience who are interested in science related topics, people who are interested in environmental resources, and people who are interested in knowing the involvement of natural resources. So the learning outcomes of this slide will be, you guys will come to know what is nuclear energy, what is the situation of today's nuclear power, what is the history of nuclear energy, what are the effects on the economy by the nuclear energy, what are the nuclear weapons which were produced or invented, and what is the development of nuclear energy in the coming future. So nuclear power, let's start with the lesson. Let's start with the first set of slides. So before starting with the lesson, let me have a quotation. The power, it does not corrupt people. It's the people who corrupt power. So let's start with the lesson, nuclear energy. So nuclear energy, it is made from power plants. It is the splitting up of the nuclei into heavy atoms or splitting up of the nuclei of heavy atoms. Uranium is used as a main fuel in the nuclear energy. This splitting of nuclei, it actually releases a large amount of energy, and it is also a non-renewable resource of energy. So you can see the nuclear power plant here and how much the emission it is actually releasing into the atmosphere. You can see the reactors as well. So this is the main components in a nuclear power plant or in a nuclear whole thing. So you can see the containment building over here. You can see the water vapor coming out of it. You can see the tower, which is also known as the cooling tower. You can see the turbine, the generator, the transformer for supplying of the electric current. You can see the condenser and the pump over here for condensing the liquid as well as pumping the liquid to higher temperatures. You can see the steam generators, the control rods. You can see the uranium fuel, the fuel rods over here, which is actually, this is the housing of a nuclear reactor. So this is the reactor vessel you can see over here. And the cool water source you can see over here, and how it is actually passed through the cooling tower. So actually this is the fuel uranium which I was talking about. This is the main fuel used in the nuclear energy purposes. So nuclear energy, actually it has two types of nuclear reactions, namely fission. The fission of the nuclei is done by the same heavy elements, and it is used in power stations for marine propulsions. And fusion of the nuclei, it is of certain light materials. The controlled release of thermodynamic power from the fusion reaction is being carried out, but it's only for applications that has been limited to relatively uncontrolled release of power, as in case of hydrogen bomb. So this fusion reaction can be seen only in hydrogen bomb and only in some limited applications. So you can see here, this is what the fusion is, and this is what the fusion is, and this is what the fission is. So fusion, it is the splitting up of particles, and fusion, it is actually the splitting up of particles getting joined into a single particle. Let me explain this. Actually, deuterium and tritium, they are actually combined to form lithium. So that's what has happened here, and uranium-236 is divided into barium as well as krypton. So what is the state of today's nuclear power? 20% of the world's electricity is actually got by the nuclear power itself, and it actually produces around 8% of the electricity in US. 69% of the US non-carbon electricity is generated by the help of nuclear power. It has more than 100 plants in the US, that is the America. It has more than 200 plants in Europe, with the France leading with the more number of plants. About 80% of its power is from the nuclear energy itself. So you can see here the nuclear power plants. So they are placed actually at relative distance. They are not placed together cause they release very emissive hydrocarbons which may lead to harmful effects in the oxides. So they are placed at a relative distance to each other. So today's nuclear power, let me discuss about the first power station. The first power station was called the Calder Hall Power Station, which was in UK, Britain, in the year 1956. The energy for the nuclear fission is used as oil water to make steam, which in another step it turns the turbines, which is useful for the generating of electricity. So you can see here, this is the Calder Hall Power Station, the first power station which was produced. This was the Calder Hall Power Station when it was at the building stages. So the history of nuclear energy is both simple and complex. The fissioning neutrons produce great amount of heat. The heat placed in the water makes steam. The steam accelerates the turbine, which in turn powers a generator to make electricity. It can only be managed by human assistance and creativity. The toxic waste and the remains will be deadly if they are not used for billions of years. And there are more than 30 countries nowadays which operate nuclear power stations. So the effect on economy when you use nuclear energy will be, it helps in the cost competitive sector, that is nuclear power is cost competitive when it is compared to other forms of electricity generation, except when there is direct access to low cost fossil fuels. So the fuel cost of nuclear plants are in a minor proportion of total generating costs through capital costs. So that is what I have told here, the minor proportion. And next, going to the decommissioning and waste disposal. In assessing the economics of nuclear power, decommissioning and waste disposal costs are fully taken into account. It also helps in the direct cost savings. It also helps in the fossil fuel price capping. It also helps in the energy and supply security. It also helps in avoiding the net fuel imports. It also helps in enhanced technology experts. It also helps in electricity price stability, and it also helps in intellectual capital gains. So let's move on into the nuclear weapons. So nuclear weapons, namely the atomic bomb, it was actually discovered by Leo Szilard in the year 1960. It is based on the reaction. It is based on the fission reaction, and it uses the main uranium fuel, that is a U-235. The U-235 it actually blasts out after splitting. Thus, it gives energy for the atom bomb to power. You can see here, this is the image depiction of an atom bomb which was used. So next, going on to the another nuclear weapon. This is the hydrogen bomb. The hydrogen bomb was created in the 1950s. It is actually the combination of deuterium or tritium. It is actually a fusion bomb which works by having a fission bomb as trigger. When the fission bomb explodes by giving out heat and neutrons, it turns the lithium into tritium and then compresses the tritium. So you can see this is a hydrogen bomb. This is the image representation of a hydrogen bomb. You can see the components inside a hydrogen bomb. You can see the gun barrel over here. You can see the hollow uranium bullet and the cylinder target and the conventional explosive. So this is actually deuterium. This is actually tritium. Both of them, when mingled together, they give lithium. So the development of nuclear power is like this. Nuclear physics is developing into more peaceful direction. They have started to become more and more dependent on nuclear power. Nowadays, we, the people, and the nuclear power, it produces over 25% of the total electricity in over 15 countries. And there are more than 440 nuclear reactors around the world. So you can see here the nuclear physics, the splitting up of atoms. And conclusion, let's come into the conclusion. The nuclear power was discovered around 1000 years ago. It has developed at a rapid speed thanks to the nuclear arms. Everything which is related to the nuclear power has not a positive invention, has not become a positive invention. Now it is being developed towards the benefit of the mankind. It is indispensable. It is the only energy which is able to produce baseload electricity massively and completely without the green gas emission. So you can see here the green gas emission, no green gas emission. That's the reason I have put this here. So thank you guys. Any questions? Please drop those in the comments box below. You can find me at my Unacademy user platform mentioned over here. And if you have liked the presentation, please do rate this course, review this course and recommend this slide or lesson. And please do follow me or see me on my Unacademy user platform for next set of courses. Thank you guys. Have a wonderful day.